3.5, limits at infinity. Limits at infinity. If r, some number, is positive and c is a constant, then if you take the derivative as a limit approaches infinity of some constant over x to some power, and it says r is positive, why would r be positive? Well, if it was negative, wouldn't that go to the top and not be a fraction all of a sudden? So if you have a constant over some x to a power, do you understand your limit is 0? Yeah. Because if you plug in x is infinity, if you have infinity to some power under a constant, like say you have 3, an example. If I have the limit as x approaches infinity of 3 over infinity squared. Well, that's my constant. That's the r value. Okay, let's take a number, divide it by a very big infinity. Do you understand that would end up being nothing? Because it would be such a small fraction, it basically is 0. You got to understand that concept. Here, you can tell it's a negative infinity. Even though the bottom's negative infinity, it's still going to be a number over a very small, a negative infinity number. It's still going to be 0. It's just still 0. Doesn't matter if you're going to positive or negative infinity. The answer is 0. If you have a constant over infinity to whatever power, it's 0. Horizontal asymptotes. Horizontal asymptotes are asymptotes that are horizontal. And a graph, what happens is it comes up and it goes up along that and never passes it. Now, horizontal asymptotes, if you take the limit as x approaches negative infinity, if your answer as you take a limit to infinity or negative infinity, if your answer is a number, do you understand your graph is an asymptote? If you keep plugging in numbers, bigger and bigger and bigger numbers into a function, and those numbers get closer and closer to a certain number and don't keep growing, they just get closer and closer to a specific number, number L, then won't that number they're getting closer to be an asymptote? It's kind of describing the characteristic as it's going closer and closer to this value. It's called a horizontal asymptote. It's characteristics at the end of your graph. Positive, negative, or positive. So, the L value, the limit, the output of that limit is your horizontal asymptote. So if you take a limit as it approaches infinity, the output, if your answer is a number, that number is your horizontal asymptote. It's a characteristic at the end of the graph. Do many graphs have horizontal asymptotes? No. Most go on forever up and forever down. But some will go towards an asymptote at the end. And those ones, the L value is your asymptote. Indeterminate form, if you take a limit as x approaches infinity, if your answer is infinity over infinity, that's called indeterminate, because it's just indeterminate. So, if a limit results in indeterminate form, infinity over infinity, then divide both the numerator and the denominator by the highest degree in the denominator. That's a lot of words. It'll make more sense once we see some examples. But this right here, this concept is actually pretty important, but it'll make more sense when you see some problems. I'm not going to try to describe it to you right now.